Welcome to the High Voltage Forum of Hitachi ABB Power Grids, and welcome to this panel session, which is about the role of power grids in carbon emission, or the contribution that power grids play in the energy transition. My name is Christian Ohler. I'm the Global Portfolio Manager of the business unit High Voltage Products in Hitachi ABB Power Grids. And my role here is to moderate this panel discussion. Many people think, when they think of the energy transition, mainly of the transition going from classic power plant fossil fuels to wind and sun. But here in this session, we want to concentrate a little bit on what's really the role of electricity grids, so power grids, in helping with this transition, and also what are particular topics for power grids when we think of this long path that we have to take in the energy transition. And I'm really happy that we have such a nice panel here virtually together and representing different functions, different stakeholders in the, let's say, in the value chain of power grids. And so I want to introduce to you the people that we have here. So first, welcome to Angela Halbrock. Ms. Halbrock is the Sustainability Officer at Amprion. Amprion being, as most of you know, one of the 4 big transmission system operators in Germany. So welcome, Ms. Halbrock, here to this panel.
Thank you very much for the invitation.
Then it's also my pleasure to welcome Monsieur Olivier Grabet. Olivier Grabet has for a long time been board member of RTE, the only French transmission, or say the French transmission system operator, and Olivier Grabet is a senior executive vice president of RTE, currently in charge of European industrial affairs, but also with a long background in R&D related to smart grids and also to the energy transition. So welcome, Mr. Grabet, to this panel.
Thank you for the invitation as well.
And then it's my pleasure to welcome Professor Christian Frank. Christian Frank is the professor for high voltage engineering at ETH Zurich, so the Swiss Federal Institute of Technology, and has all his life experience of research on topics that relate to high voltage and to power grids. So welcome, Professor Frank, to this panel.
Thanks. Happy to join the discussion.
Also, welcome to David Wright. David Wright has the nicest title of all of us. He is the Chief Engineer of National Grid United Kingdom, and National Grid also with operations in the United States. So welcome also to you, David, here on the panel.
Very happy to be here, Christian.
And then, hello, Markus Heimbach. Markus Heimbach is coming from the company Hitachi ABB Power Grids, and he is the managing director of the business unit High Voltage Products. Welcome, Markus.
Thank you, Christian, and a warm welcome to everybody.
So let me start maybe with Ms. Halbrock. You have the nice title of being the head of sustainability, or really responsible for sustainability in your company in Amprion. And I'm just curious, what's on your desk each day? Like, what are really the topics of in the sustainability for a transmission system operator like Amprion? Just give us maybe some flavor of what are these topics and what's your policy in those to get started.
Yes, Amprion is a transmission system operator operating the electricity transmission grid. But we have a holistic approach in sustainability. So what is on my desk are the whole topics of sustainability. So all dimensions are enclosed here, and we have 5 fields of activities concerning the electricity grid, concerning environment, concerning employees, and and all that stuff, governance we have, and this is on my desk. So it's easy because sustainability is part of our core business. So we are acting in the common interest as a transmission system operator. We ensure system security, and we play a role as an enabler of the decarbonization because we build the infrastructure to integrate renewable energy. We give access to the grid, and we include them in our system operation management. And this is one topic I deal with. On the other hand, we have environmental issues. So if you build the infrastructure, it's very important to do it in harmony with nature. So nature conservation and route management is very important for Amprion to look on species. But we also have these general issues like employee issues, development of employees, diversity is on my desk, and governance. We have a look on our supply chain management. This is very important for us. On the one hand, human rights. On the other hand, it's green procurement, which we focus on. And of course, Amprion wants to contribute as a company to decarbonization. So we have our CO2 balance sheet, and we want to improve it and save emissions in the future.
Thank you, Ms. Halbrock. So somehow this was a perspective from Germany. I'm now looking to France. Monsieur Grabet, do you have similar topics when you think of the topic of energy transition and sustainability as a transmission system operator? Or do you want to add to what Ms. Halbrock has said?
I think that we have a lot of common point with our European TSO colleagues, and we work hand by hand, in fact, to tackle all those challenges. But perhaps I can highlight a few specific points on the strategy that we develop, in fact, also to have this global approach for the energy transition, which is not only an energy transition, but also an ecological transition. Last week, we had in Marseille the International Forum for Biodiversity. And so what we do is, as Angela said, to have an holistic approach. And so how we can make links between the different topics, and even for to take this example about the biodiversity, that seems not to be a very specific concern for TSO, but as a grid cover all the territory, we think that we have a responsibility in that, and we have to consider also those type of topics in our strategy. So I mean that as most of the energy company, we are fully committed for the success of the Green Deal, and as a part of the electricity supply chain, we all know that the electricity will take an increasing share in the energy sector for the next decade, and so we have a special responsibility. And so perhaps I can summarize about three main points that we consider. First, we have to consider not only the technical issues, but the global footprint of our activity. And so one of our main concern is how to adapt the existing grid to the new paradigm, not to build new infrastructures. We need new infrastructures to connect, for example, renewable wind farms, so on, but also we have an existing grid, which is quite very important, and that proved in the past in Europe that is very reliable. And so it's a big challenge for all of us to adapt it to the new paradigm. And so it can be made considering two things: a close combination between classic assets and digital solution, and also how we can develop a synergical approach with the grid users. I mean by that, we need to develop the flexibility. Sometimes, for example, for renewable, we need also to have what we are calling the smart curtailment in order to have a global optimization and not to consider sector by sector, in fact, how to optimize its own business. The second aspect is, in order to tackle in this holistic approach the issue that you are facing, so we consider that eco-design should be the socket of our project. And so we have a very, now for more than 5 years, we developed eco-design in order that the business consider that it is one of their concerns, so to develop new methods. And doing that, we need also to work with all the stakeholders, and especially with technology suppliers, which is not an issue because it's a very innovative. And in this framework of eco-design, we have a specific technological issues, but also environmental issues, and especially when I spoke about biodiversity, how we can have what we are calling a regenerative approach in order not only to reduce the footprint, but sometimes to find strategy that help the nature to develop again. And the last, but not the least, we have also to consider the business model, because unfortunately, the framework for the TSO is a framework that has been imagined 20 years ago just to open the market, not considering all the concerns that we have today. And so the regulatory framework is not fully adapted to the challenges that we are facing. And we have to discuss about that with the regulators, with the commissioners, in order to open new business for the stakeholders. When I spoke about the flexibility, we know they need this flexibility, but we do not know how to manage the revenue flow, in fact, so that it can develop as we expect it can be.
Thank you. Very inspiring. Like David, you now have a UK view, and you also have a United States responsibility. So do you? And I know that sustainability is very close to your heart. So maybe you add your thoughts, like from perspective of National Grid.
Yes, thank you. I think we all know the climate change and how we respond to it is probably the engineering challenge of the 21st century, and so similar to Olivia and Angela in their remarks, we've been really thinking about how do we address it strategically. And so we've made a pivot in National Grid's business towards electricity. We bought the largest UK electrical distribution company. And whilst we still have gas businesses in the US, that pivot to electricity is very much around UK and US getting a strong set of assets across the whole of the chain, from distribution through to transmission. And through this, we sort of recognise we've got that leading role that we've got to play in the industry, which is why, together with Hitachi Energy, we're one of the principal partners for COP26, and I'm really pleased we are. From a sustainability perspective, though, our approach is really much aligned to thinking very hard about the UN's Sustainability Development Goals. And as a business, we've put out our own responsible business approach, which we think really underpins the approach that companies like National Grid need to take right across the sector. And that covers 5 key areas. First of all, and most importantly, it covers the environment and our own emissions, and how we make sure that we create that fair, affordable transition for all. And doing our bit based on science-based targets to get to where we need to get to. The second key area is about communities, and really making sure that we have a positive impact in all of the communities that we serve, both through the investments we're making every year, but also through commitments on volunteering and development of people in our communities. So they've got the skills needed to respond to the net zero challenge. We're focusing on our people and making sure that they're both treated fairly and they got the opportunity to thrive during the course of their career at Grid. The economy and how we contribute to the economy of the country in which we operate. And finally, governance. We're committed to the highest level of corporate governance that we've got. So that's sort of our approach to sustainability, how we're thinking about it strategically, and then how we're being really transparent about what we stand for, our approach. And each year we're publishing a report every year so everyone can see what progress we are or are not making.
So thank you, David. Now we have heard views of 3 utilities or transmission system operators, rather. I would be curious, Professor Frank, from academic point of view, like just the connection between power grid operation and energy transition, what are research topic that kind of keep the researcher interested and busy in this topic?
I mean, the areas is large, and I can mainly speak about what we're interested in. And if I think from the grid perspective to environmental impact, there's on the one hand, of course, is the losses. But if we solve the problem of generation, of getting rid of fossil generation, then also the indirect emissions via losses is not that relevant anymore. And then comes the question of what's the impact of the assets, of the components itself with respect to the environment. And one of the largest or the longest standing research topics that we have is the question of getting rid of SF6 for electrical insulation. So the emissions caused by the use of SF6 are, you can quantify it, you can make a simple estimate to get a figure for the relevance. If you look into the concentration, the increase in concentration in the atmosphere, then you can deduce what's emitted every year. And you can make a simple estimate just by looking into these rates of increase. It's parts per trillion, so not very much, but the global warming potential of SF6 is 23,500 times more than that of CO2. So you have to multiply this, and then you can compare it with the ppm increase of CO2 to the atmosphere. And then you see it's in the order of 0.3%. So that's a figure. It's not the most urgent problem right now, but you have to keep in mind that these are emissions. It's not like you stop burning fossil fuels and then you stop the emissions of CO2. We're talking about leakage here. It's equipment that contains SF6, and only a very small percentage of it, let's say 0.1 to 0.5% for new equipment. Maybe it's a little higher for old equipment, but this is what's leaking out. So you cannot simply stop these emissions because it's banked SF6, and there is a potential hazard of a factor of 200 to 1,000, which is still lingering around and could be emitted as well. And there is no natural source like for CO2, so we can't just grow trees that absorb SF6. So even though the number seems not high, and unfortunately it's often misused as an argument for not caring about this, but yeah, I think it's a very relevant problem. Not the most urgent one, which we have right now, but in the next 1 or 2 decades, it can become one. So it's very important to look into it. And from a research point of view, it's a super interesting topic. It combines several disciplines: electrical engineering, gas discharge physics, material science, chemistry. And this is, I mean, my favorite research topic because it combines so many disciplines. And also the researchers which I have in my group, doctoral students and master's students, are very fascinated by this topic. So it's a good time to work in research.
Thank you, Professor Frank. Maybe Markus, before moving directly head on onto SF6, but you are representing here the view of an equipment manufacturer in like a company producing assets for the power system. What is in reality the best an equipment manufacturer can contribute to make for the carbon neutrality of the power system?
Thank you, Christian. It was as well very interesting and exciting to hear the views from the TSOs here, but as well from the research. And what we see here to basically support the energy transition, going from the coal or oil or whatever and the gas towards the renewables, we see that all industries are pushing more and more for electrification. And what we can basically say is that in order to reach a carbon neutral energy system, the electricity will be the backbone of that system going forward. And what we can estimate for the time being is that whereas now electricity stands roughly for 20% of the total energy consumption, we assume that by 2050, when we want to reach in a lot of states and regions, when we want to have reached the carbon neutrality, it will be double percentage-wise, so it will be in the range of 40%. And this just simply shows how important the high voltage grid and how important the overall backbone will be, because the grid is the backbone and delivering the electricity to the households, but as well to the industry going forward. And when we then look into that one, and I liked very much what Christian Frank was saying, is that SF6 is a problem, and we will focus later on that, but that is for the time being not the largest problem, because we need first of all to make sure that we get the energy which is done in the energy generation which is done in the windmills or in the solar panels. We need to make sure that we get it from there to the households through the electrical grid. And here it is extremely important that our equipment is reliable, meaning that we ensure the TSOs, that we ensure the industry, that we ensure our customers basically that the energy generated gets safe and reliable from one piece to another. And with the whole energy transition, we will have as well much more fluctuating sources. And we have even, because a lot of people are thinking that you put the solar panel on the household and then you just are self-sufficient, that will be not enough. So we will have as well remote sources or remote supply from there. So the energy system, the grid, will be even much more fluctuated and will have as well more loads to come, which is very interesting for us as a company, because it needs equipment, but it needs reliable equipment. And here as well, we had recently the SIGRE, which is our main conference for that one. And the most important thing as well to go for the customers and utilities to go for neutral or for eco products is that these products are reliable. And based on that one, for sure, we can as well contribute going forward on more sustainable, and that means for us in the high voltage switchgear for SF6 free products and alternatives.
Thank you, Markus, for this view. Ms. Halbrook, you said some quite interesting thing before, and also when I read the sustainability report of your company, what fascinated me is the outreach part, or like you are really, I think, thinking a lot about how to address the various stakeholders that you have in these topics. So I would be curious. So how do you interact, or like what do you do for kind of talking to these different groups of people and so on?
Yes, thank you. And we have published our new sustainability report on 1st of September. So if you're interested, we give a follow up, and there you can get also some figures and numbers again. Yes, stakeholder management is very important. It's not only important from a sustainability point of view, it's also important for our core business. So we build huge infrastructure projects, and we are operating in a truly diverse field of interest. So we do stakeholder communication in our project. We have project communication, but we also listen to what our stakeholders say. We have dialogue in the region, and we try to adapt our projects to fit best to the regional needs we see. So,
and is it mainly politician, or is it kind of normal people, or like citizen that you address?
Yeah, it's both. It's both. We have lots to do with politicians and authorities to agree what we can do and what are the needs in the region. But it's also society, people who live close to our roots. We talk to them and we try to figure out their interest and come with the appropriate solutions. Yes.
Mm-hmm. Okay, thank you.
Can I add something?
Yeah, sure.
So I'm as a professor, the role is not only to do research but also to teach, of course, and there's a certain outreach aspect in it as well. And I can fully confirm. So I was really surprised. I mean, of course, I expect that all students working in or studying in the energy area know about the climate change and the energy transition that's required. That's true. But what surprised me was that very few of them are aware about the extreme urgency of the problem. So, for example, the IPCC report that gives us these scenarios, half by 2030, and this is 9 years from now, zero by 2050. This was not so much in their minds, and I think this also goes for the public. So everybody agrees, yes, we need new renewables, but they don't see the urgency of the problem. They don't know that it maybe involves having existing lines or maybe even building new infrastructures. So I think this, we as a community of engineers and people working in this area have a job to do there as well, and to communicate much more of what is really needed, and to give visions and specific scenarios. Not only do you want renewables, but also what does it imply to your lives and to the landscape and so on. So this is a very important aspect as well, besides providing the technology.
Yes, I fully agree. You can only build lines or improve lines if you cooperate with the people, if you cooperate with the experts. So if you investigate the environmental needs, and then you have some environmental experts to talk about what we can do and how we can reduce our impact in the region. And then so this is a common project. You cannot do it on your own. You need authorities, experts, all opinions, and all the people living here, that they can say their interest, and that then you can develop common solutions.
Exactly.
Yeah.
Yes, if I can add, I think that we used to speak about the challenges that we are to tackle, and I think that, as Angela said, we have also to speak about what are the good way, in fact, to tackle that. And so we need more cooperation. And to take the example of the SF6, so we try to work more closely between the different TSO to align our view, our project, in order that the industry can tackle the issue. In another field, for example, DC technologies, we know that those technologies are crucial, in fact, to develop the offshore capacity that Europe needs, in fact, to reach the neutral carbon objectives. But at that time, we do not have interoperability of the technical solution. It's a big issue, and all the stakeholders, I mean the TSO, by the aligning their specification, but on the other side, the technology supplier being able to work together to provide interoperable solution will be also a big challenges, because otherwise it will be a waste of time, a waste of money, and so we have to find a new way to be at the same time in cooperation, keeping some places for competition. How we can combine this cooperation and competition, it is a very important issue, and we have to learn about that. And I mean that on the academic side, I think that it's also an issue how the students will be able to enter in this new paradigm, in fact, a new way of work together.
And
Thank you.
May I add something from our side here, because I like very much as well from a people side point of view. One topic is for sure that we need to work more together as well from a manufacturer point of view to find different or more common solutions, standardized solution, and this needs as well to be worked within manufacturers, but as well within people. But what I want to add here, which I think is as well very important, is our industry was a little bit sometimes considered a little bit old-fashioned, boring, and so on. But this new challenge we have is putting a huge motivation for our people, because it's not so that they need just to develop something completely new as a product, which they have done before, in order to fulfill something like current interruption, like insulation. But they're as well doing something very good for the society. And this is a huge motivation factor, which I don't think it's not only for the students, or which I know it's not only for the students, but it's as well extremely important for our researchers and for all the people involved. I see this huge motivation in all our company there.
So David, maybe I know actually the UK is among the most advanced in also regulation on SF6, and your company really has a very consistent policy in that regard. Maybe you can walk us a little bit through your attitude or like your policies specifically for the SF6.
Yeah, very happy to. I think when we think about our own emissions as a company, we own some fossil fuel generation on Long Island in the US, which will be closed shortly. We've then got the issue of the electrical losses that Christian's already spoken about. UK grid is now generating more electricity from non-fossil fuel, from zero carbon sources than it is from fossil fuel. So we're well on the way to addressing those losses. So when you then start to think about, well, what's the next largest contributor, you actually get to SF6. And it's the one that I worry about the most, actually, because it's the one with the longest life, 40-year assets out there. So we've been really challenging the supply chain, but also doing a lot of industry-leading research into finding different insulating gases. We have changed our policy inside the company. So we think alternative technologies are now available at 1 through 2 kV and below. And so we're not buying any more SF6 products at or below that voltage level. It might be slightly more expensive to buy some of those alternative products, but you got to take the industry where you want to, and we don't want to create any more of that stranded product. We've also taken the decision not to buy any more SF6 as a gas. We're only going to buy recycled SF6. And a few years ago, we trialled in one of our 400 kV substations gas-insulated busbar from GE, the G-Cubed product. And we've proven it can operate really reliably over the last 3-4 years. And so we're happy to be, that prime mover. We're not going to put any more SF6 in GIB. But also looking for the new products at 275 and 400 kV, traditional transmission voltages, as soon as they become available onto the market. We're really keen to make that switch, to start buying those products and addressing it. So that's the new equipment. But I think the other challenge we've all got as utilities worldwide is the whole issue of our installed volume of SF6. We've got over 1,000 tons of SF6 on our network at the moment. And so that also needs innovation and addressing it. It needs innovation and addressing it, first of all, in minimizing the leaks, of which there's quite a few, both from the permeability of the seals, but also corrosion. We see quite a bit of corrosion around the flanges. But more importantly, the more systemic and longer term is, can we work with people to develop an alternative gas that you can retrofit into the existing assets? Yes, of course, there's the opportunity over, between now and 2050, over those 29 years, to potentially replace some of those assets early. But that's throwing money away. And I'm sure worldwide we really don't want to do that. So finding that retrofit gas solution to put into our existing assets is a massive part of the solution here. So those are just some of the things we're doing.
Maybe, Professor Frank, I'm looking at you. Can you give us a 3-minute lecture? Or what is so unique with SF6, and why is it actually not so straightforward to replace it? Or why are people so having such a hard time to do it?
So I'm not sure if I managed in 3 minutes, but I can give it a try. So of course the property we think of first is its electric insulation strength. So a discharge, this is what we want to prevent, means motion of charge carriers, basically electrons. And there's gases that have certain properties that favor or disfavor the amplification of these charge carriers. And SF6 has the ability absorb slow electrons, binding them to their core and decelerate them and more or less take them out from the discharge. There's a lot of gases that have the same properties. There's even a lot of gases that can do this much better than SF6. But what is very unique of SF6 is its boiling point. So that means you can fill it with a high pressure, and pressure helps. It's kind of doubling the pressure, doubles this benefit of moderating the discharge. And if you can do this to very high pressures and also at very low ambient conditions, which we have -degrees in our climate in winter, then this is favorable. So you can easily find other gases which do the same electric job, but they liquefy at low temperatures and high pressures. And this is the key challenge. So the new gas mixtures which we see, and I think this is commonly accepted now that we don't have a direct one-to-one alternative, is always gas mixtures. So there is a background gas. This may be air or carbon dioxide, CO2. And then there's a small percentage in the order of 5% of a special gas admixed. And this can lead to similar electric strengths than pure SF6. And it's a combination of finding the right mixing ratio for having the minimum boiling point correctly, plus giving the electric strength. So depending on which solution you favor, you go a little bit higher in pressure, or you increase like the size of the equipment, or you derate on the minimum boiling point. So that's an engineering challenge then. So the new gases will all be mixtures, and the manufacturers decide on size, pressure, dimension of the equipment.
Thanks. So Markus, what is Hitachi ABB Power Grid's path beyond SF6? So what will our company do?
Thank you, Christian. And let me ask, first of all, it's for us really important that we support our customers in the energy transition. So that I just mentioned before. But as well, it's very important, and David said that, but a couple of others as well, that we as well tackle the greenhouse gas. And unfortunately, SF6 being so great, as we just heard in the insulation, has the problem of being a very dominant and strong greenhouse gas. But with all the very good explanation from Professor Frank, I would like to add one important topic of SF6, which is not just the insulation, it's as well the current interruption. And that is very often a little bit underestimated. Because we would be, from an insulation point of view, the challenge would be able to be controlled easier than just to look into the current interruption topic. And what we face as manufacturer is not to get the insulation done too much, or we get it as it is for you challenge, but even more challenge is to get the circuit breaker under control. And what we have done since we have, so we are waiting, or we are working in a triangle between current interruption, insulation, and greenhouse gas. And the gas, or the gas mixture, and this was very nicely explained, will always be a compromise. Because in the end of the day, we haven't found the gas mixture which is better than SF6, and we haven't found the gas mixture which is better on SF6, both in insulation and in interruption. But we have found the gas mixtures which are essentially eliminating the carbon footprint, so the greenhouse warming potential. So, and there we have worked now for more than a decade to find a replacement. We have put as well a pilot installation, the world's first SF6-free high voltage switchgear here in Zurich. But on the parallel side, we have as well, as David was mentioning, tried to reduce and to manage the life cycle of SF6 more and more. But in the end of the day, this is just something which helps the transition. But the ultimate goal of all of us is to put a completely SF6-free portfolio into the market. And what we have done from a research and from a development point of view, we focused very much on the interruption. Because in the end of the day, we can already nowadays replace 420 kV gas insulated pipelines. But what we cannot do is to have a breaker in that 20. And here we just looked as well into what is available on the market, and we then came up as well with a solution which is based on the fluoronitrides. What I would like as well to mention is that we judge our solution from a carbon footprint point of view, I think as everybody is doing, through a life cycle assessment. And this life cycle assessment is not just taking into consideration the greenhouse gas itself, but is as well taking into consideration that to produce a switchgear, there's a lot of carbon footprint which we are creating, and as well the size of it is very important, but as well that during the lifetime of the switchgear, it's creating a lot of losses, or some losses, which we need to be as well optimized. And we try to find the optimum, which we then find in this fluoronitride solution which we are offering. So why haven't we changed, or why haven't we as well worked toward that path? And there I would like to give you 4 reasons. The first one is what I mentioned in the beginning. It's reliability. Because when we are offering, we know how to work a gas breaker, we know how to operate as well a gas insulated switchgear. We took a solution which is very similar to the existing one from the basic principle point of view. And reliability is the most important to support our customers. Then this solution is scalable, and that we believe is scalable. So it's not only working for medium voltage or for 120 kV, 123 kV. We are convinced, and we will show it the world, that this solution is as well scalable to higher voltages into the transmission level and as well to higher currents. And then, as I just said, it is the best compromise when you look, or the best solution when you look it from a life cycle assessment point of view. And that we have gone through in a very detailed work with all our researchers. It is essentially eliminating the SF6 footprint, and is then as well working and optimizing the rest of the elements of the life cycle assessment which I was just mentioning. And last but not print, and is then as well working and optimizing the rest of the elements of the life cycle assessment which I was just mentioning. And last but not least, and this was something which Olivier Gravet was mentioning in the beginning, it is opening the door for an industrial standard. Because the customers, and I'm speaking for the customers because we have listened to them very often, and when we came in before with all different solutions, the customers, they want to have a standard solution. Because it's a reduction of the training, it's a reduction of the capex we need to put into the investment, and it's something which then as well hopes that the industry is converging into that. And we do believe that this solution has the potential to become an industry standard. And last but not least, I just want to repeat what I mentioned before. I just tell you how motivated and how thrilled our people are for this challenge. Because what we are doing is we are basically developing a completely new portfolio in a very short period, which has to replace the SF6 portfolio in the midterm.
Yes, I fully agree to what all of you said. It's really challenging. And we have to focus on reliability. System security is essential. And especially with integration of renewable energy, it's more challenging to keep the system stable. So this is very important. But we also see that SF6 is a very huge part of our greenhouse gas balance because it's so carbon intense. And so we focus on that issue. And I think here cooperation is also the key. We look for standardized solutions, you said it, and therefore we, within ENSOE, we cooperate to focus on solutions regarding SF6. And what Amprion did was improve the leakage management. It's very important to reduce the leakage in the first step. So we focus on that, and we made to reduce our SF6 leakage during the last years, and we improve the method. We go for online technique and so on, just to reduce the leakage. But we have also to look on this SF6-free utilities. So we cooperate with manufacturers and with all of you to introduce pilot project to foster technologies which we can use. So this is really challenging, and it's on our agenda.
Okay, thank you very much. Unfortunately, the time is 45 minutes are very short, and I would like to thank you very much actually for giving the various viewpoints that you brought, and for me it was an interesting, very interesting learning, also preparing this session. So thanks a lot. So with this, I conclude this panel on the role of power grids for the carbon neutral energy system. Before you leave, I want to make the final remark. Now, the company that is kind of hosting this high voltage forum is Hitachi ABB Power Grids, but just in a few weeks from now, our name will be Hitachi Energy, and we hope that everybody still remembers this is the old ABB high voltage, and this is why we are saying it frequently. And with this, I also hope you enjoy the other sessions that are part of this high voltage forum for participating here, and thanks for the audience for watching. So wish you a nice rest of the day. Bye-bye.
Have a nice day.
Bye-bye.